Hello, in this session we will talk about what is MongoDB. This is Hassan Mir from 02protraining.com. So what is MongoDB? A simple answer is it is a document-oriented database. It is an open source product and is developed and supported by a company called 10gen. MongoDB is available under general public license for free, and it is also available under commercial license from the manufacturer. Now it's time to take a look at the definition given by the manufacturing company 10G. MongoDB is a scalable, open source, high performance, document oriented database. We will look into what does scalable means in this context and why there is so much talk about high performance and what is document oriented. First thing first, so we understand that MongoDB falls into a class of databases called document oriented databases, and understand that document oriented databases is a class that falls under a broader category called NoSQL databases. If you zoom out further, you will notice that overall databases could be classified as one of the three groups: relational databases, known as RDBMS, Relational Database Management Systems; OLAP databases. OLAP stands for Online Analytical Processing. Some databases claim to work in both the systems, RDBMS and OLAP, like SAP HANA, yet we have some vendors that create databases just for OLAP purposes, like Oracle Express database. And then we have this third category, and this is a recent development, and this is known as NoSQL databases. So let's take a look at a little bit history behind the creation of NoSQL databases. Back in time before 1970s, we used to have flat file systems. Data were stored in flat files. The problem was that each company had their own implementation of flat files. There were no standards, and a lot of energy and efforts were spent in programming how to write data back to the files, how to retrieve data from files, as there were no standard way of storing the data. In 1969, COD gave a relational theory, and based on that, few relational databases were created, and these databases answered the problem of having no standard in the way data is stored. So now there was a standard way of storing data and a standard way of querying the data. So in the programs, now we will only write what do we want to query. How to process that query is now a headache of relational databases. So everything was good, life was perfect. Relational databases were the answer to the problem created by flat file systems until the data became too big. You can take my other video on what is big data, and this is a recent terminology that came up on the scene because of the data explosion. Relational databases are incapable of handling the big data, and that is by the virtue of their design. They are not horizontally scalable. No matter it's SAP HANA or Oracle database, relational databases are incapable of handling the problems created by big data. So as an answer, NoSQL databases spring up on the scene. The main idea behind NoSQL databases is horizontal scalability, which was missing in relational databases. Horizontal scalability simply means you keep on adding more and more computers as you need more and more power. So they are not any special computers, they are simply commodity computers. So you need double the performance, so double the number of your computers. Performance is linearly proportional to the number of computers. So that is horizontal scalability. So now we know where NoSQL databases are coming from. Broadly, they could be divided into three subcategories: key value stores, tabular databases, and document-oriented databases. Key value stores store information in pairs of key and values, and here are some examples: Memcached, Coherence, Redis, etc. By definition, Memcached is a relational database, but it is a key value store as well. And then we have tabular databases. Examples are Bigtable database from Google, HBase from Apache, and Cumulo from Apache as well. They store data in tabular format, and then we have document-oriented databases like MongoDB, CouchDB, and Cloudant. Document-oriented databases store data in document format, as we will see later. Okay, so we understand the history behind NoSQL, the broader categories of NoSQL. What is the main difference between NoSQL and relational databases in practice? So mainly these are the features missing from NoSQL. Joins are not supported. Complex transactions are not supported, meaning you can't say first insert these two records and then update this and then delete this and finally commit if this is the condition, otherwise roll back. So rolling back of multiple transactions is not supported by the NoSQL databases, and constraints are not implemented at the database level, they are implemented at the application level. Okay, so we know few things are missing, but obviously they are missing to provide some extra features, otherwise what is the benefit? So here are the extra features that come with NoSQL databases. They have a query-like language. This is not really an extra feature, but this is just a clarification that NoSQL doesn't mean you can't query databases as the name suggests. This is a very misleading name. There are query languages are available, and they are faster in performance, much faster as compared to relational databases, and they are horizontally scalable. They can handle much more data than relational databases. So here is a summary. This will give you a clear comparison. Relational databases offer much more functionality than NoSQL or non-relational databases. They are also referred to as non-relational databases, but the real name would be NoSQL. However, performance of NoSQL databases is much more than relational databases, so there is a trade-off. Let's do a quick comparison between relational databases and a MongoDB. So table in a relational database would have records, and an entity is represented by a table, and each record is representing an instance of an entity. For example, employee is an entity, and Hassan would be an instance of an employee. Maybe Bill would be another instance of the employee. So a table employee would exist in a relational database, and one record would exist for Hassan, one record will exist for Bill, etc. In MongoDB, table is comparable to collections. We will have a collection called employee, and then within this collection there would be one document for Hassan and one document for Bill. In a relational database, we have multiple schemas, or synonymously you can call them users, and within each schema you create objects like tables, and there is a kind of partition between schemas. In a relational database, if you go within a table, you will have multiple records, as I already explained, and each record is representing an instance of an entity. And within each record, there will be multiple fields. For example, here we have 20 department for employee Hassan. Now let's compare the same scenario with the MongoDB format. Okay, so MongoDB is a document-oriented database. It stores documents within a collection, and collection is equivalent to a table. So what you're seeing on the screen is equivalent to a table, and this format is called BSON format, which is very similar to JSON format that is available in JavaScript. Okay, so this whole box that you're seeing on the screen could be called a collection, and this collection has multiple documents. It has 3 documents, one for Hassan, one for Bill, and one for Larry. And the document may also be called object sometimes. As you can see, a document is comparable to a record or row in a relational database, and a collection is comparable to a table. If you zoom in within a document, you're going to see various fields. The first document has 4 fields, and a field is a key value pair. First name is a key, value is Hassan. Last name is the key, value is Mir, and so on. In BSON format in MongoDB, the ID _ID field is mandatory, and it could be considered equivalent to a primary key in relational databases. In a relational database, all the records going in one table must have same number of fields. However, in MongoDB or in other document-oriented databases, these are not the requirements. Okay, so the first document has 4 fields: ID, first name, last name, department. ID is mandatory in MongoDB. The second one has 3 and the third one has 5. So this format is very flexible compared to what we have in relational databases. Also, this is another example. Take a look at this project field. Project field has multiple values. So let's say this is another collection where we are storing which person is involved in which projects. So you can see Hassan is involved in 2 projects and Bill is involved in only 1 project. And here we are storing 2 project names within 1 document. And here we are storing 1 project name. So one-to-many relationships can go that easily in MongoDB. So this is something to note as a comparison between relational databases and document-oriented databases. And here we are storing embedded data model. We have created an embedded object here. So person Hassan has multiple addresses, 2 addresses in this case, and address itself has multiple attributes: street, city, state, and postal code. So you can see how easily we can store embedded objects within an object. This is just an overview video, so I'm not going to go in details. I'm just giving you high-level points as a comparison between the 2 types of databases. In a relational database, we have an SQL, structured query language. In MongoDB and other document-oriented databases, we do have query language. So no SQL doesn't mean we cannot query. This is just an example. This is a query going against collection employees, and find is a keyword, and we are saying give us the record where ID is 123, and here we are saying give us the record where the name is Hassan. You can use wildcards as well, and here we are saying find everything from the collection employees and sort the result by the name. So these are just few examples. In other videos we'll go deeper into the querying, but this gives you an idea that SQL-like language does exist. Now we'll talk about some of the features of MongoDB. As you have seen, it does support ad hoc querying. You can do a search by field, range queries, and you can do regular expression searches. And indexing is supported. Any field in a document could be indexed. Master-slave replication is supported as well. So master can perform reads and writes, and slave copies data from the master and can only be used for reads or backups. Writes are not supported on the slave. MongoDB runs on multiple servers, and data is duplicated to give protection against hardware failures. So this is a built-in feature of MongoDB. Keep in mind that when we talk about big data, then we are talking about distributed computing on multiple computers, as we do not have any other choice. Any solution that is geared towards big data will have multiple computers involved. So whenever we have multiple computers involved, we will have hardware failures. And so the protection against hardware failure has to be built into the software. Automatic load balancing is also a built-in feature of MongoDB. As we have already talked about, scalability is the salient feature. In fact, MongoDB is built from ground up to offer scalability and performance. Capped collections are supported, which could be imagined as a circular queue. Horizontal scalability is what it offers. You can add machines to a running system. MongoDB has a special support for file storage functions. Feature called grid FS is available for this purpose. MapReduce feature is available in MongoDB, and it offers the same functionality as group by clause in SQL. So aggregation is available through MapReduce. Keep in mind that MapReduce feature is not as sophisticated as in Hadoop, and I've talked about that in separate videos, but it does the job. So MapReduce is where you divide the computation, the big computation, into smaller pieces, and you send each piece to a smaller subset of data, and once each small piece of computation is finished, you aggregate the results back. In the query language, you can use JavaScript functions, and that is a very strong feature of MongoDB. Another interesting feature of MongoDB is that it offers special support for locations. It understands longitude and latitude natively. So you can store locations in terms of longitude and latitude like this comma that, and then you can do interesting queries. You can say, okay, show me all the other places that are within this many kilometers from this location. You can specify a box, show me everything that is falling within this box, etc. So location is something very native to MongoDB. MongoDB does support capped collections, which could be imagined as circular queues. So let's talk about a brief history. The company called 10gen created MongoDB in 2007, and it was production ready in 2010 only, with its version 1.4, and the recent stable version available is 2.4 in 2013. There are lots of companies who are already using MongoDB. Here are some famous clients: MTV Networks, SAP AG, which is a popular ERP company, Craigslist, MTV, Foursquare, and SourceForge. The database is available for various platforms: Windows, Linux, OS X, and Solaris. Another important thing to note is that although big data has to play a big role in the creation of NoSQL databases, including MongoDB, but MongoDB could be used in big data applications as well as in traditional applications. MongoDB is a very suitable candidate for smaller applications as well, but keep in mind, if you have complex transactions in the picture, then MongoDB might not be a suitable solution. You have to then rely on a relational databases. Complex transactions meaning, as already mentioned, you are doing multiple inserts and multiple updates, and then you are committing the work at the end once certain conditions are true, otherwise you're rolling back. Relational databases are used with programming languages like PHP, Java, and so on, and most of these programming languages are object-oriented languages, meaning they are storing the information about the instance of an entity in an object format, while the same information is going in the relational database in relational format. For example, if one employee is involved in 3 projects, so the information of the project will go in the projects table, information about an employee will go in an employee table as records, and each record will have multiple fields and so on. While the same information is read from the relational databases, it is captured in the program in an object model. So a conversion has to take place, and this conversion is very costly in terms of the efforts, and this is where the most headache comes from when using relational databases in object-oriented programming languages. Good news is that it's very easy to use MongoDB in object-oriented languages, and that is because the formats in which the MongoDB store information and the programming language stores information are very similar, as you have already seen. So there is no conversion headache. And also note that a very strong driver support has been provided for MongoDB, and it could be easily used in languages like Java, JavaScript, Python, Ruby, C#, PHP, and more. So MongoDB is a very good database for big data applications, but even for traditional applications it is very commonly used for these purposes: to store user account information, to store forms data for content management systems, to store geographical data, and to store application configurations, and also it is used to store logs coming out of different software. Instead of writing logs to a log file, you can write it to MongoDB so that you can do searches on the log later on. This is a screenshot from the website Indeed.com. You can see the number of jobs are going up exponentially for applications like MongoDB and even other applications that are related to big data like Hadoop, etc. So this is something to think about. You might want to spend some time investing in MongoDB if you want to be ready for the future.